Alright, in this video we'll continue with Lewis electron dot structures and just talk about how we lay out the molecules, and we'll take a look at these three simple molecules here. So a couple of things to remember with this. Let's just put one of these under there. Some hints about just laying out the molecule. First of all, the arrangement of the atoms usually is pretty symmetrical around a one central atom. You may have more than one central atom, though, depending on how complex a system you're dealing with. In a molecule of two different elements, the one with the greater number of atoms usually is on the outside of the molecule, and then fewer atoms go kind of towards the center of that. The central atom is usually less electronegative, which means it's usually more to the left and farther down in the periodic table. So when you look at that, again, it's really the way to think of it is the farther away from fluorine you are, the more or the less electronegative it will be, the more likely that's going to be your center atom. So the farther from fluorine, more likely is your center atom. Hydrogen will never be the central atom. Hydrogen's always going to be on the outside of a molecule. So even if it's listed first in the formula, a lot of times the central atom might be listed first, but if hydrogen's listed first, it's never the central atom for that. And then sometimes the chemical formula can give you some clues about the arrangement of atoms as well. And so we'll look at some examples in the next video on that. Alright, and so let's just talk about the steps that we're going to go through to balance, or not to balance the equation, but to determine the Lewis electron dot structure for these. So the first thing we're going to do is add up the valence electrons for each atom and get the total number of valence electrons that we're going to have to put into that atom. We can't use any more than that, we can't use any less than that. We have to use all of the valence electrons. And the next thing we'll do then is put two electrons, which is just going to be a single bond between each pair of bonded atoms. Then we add any remaining electrons as electron pairs around the, typically around the terminal atoms first, and then we move on to the central atom. And then this last step is only done if absolutely necessary. It says if necessary, shift unshared electrons to make double or triple bonds to complete octets. We do that just for these four elements: carbon, oxygen, nitrogen, and sulfur. And so we'll take a look at some examples of that in the next video. Alright, so let's take a look at these four. These are very simple molecules here, but again, I like to start simple and then we'll work our way up from there. So let's start over here with this one here, carbon tetrachloride. And again, the first thing we're going to do then, put this off on the side here, is we're going to start by figuring out how many total valence electrons we have to work with. So for carbon, let's start with that one. And so for this, we can tell very easily using the periodic table here. Here's carbon in column 14 or column 4A. It's just going to have 4 valence electrons that it brings to the molecule here. We don't really care ultimately how many they end up. They all want to end up with 8 essentially for that. And so then we have 4 chlorine atoms. So we're going to take 4 times the number of chlorine atoms. And so again, if we look at the periodic table here, here's chlorine in the second to last column, and all chlorine atoms are going to have 7 valence electrons for that. And so we're going to take then 4 times 7. So that's 28 there, plus another 4 is 32 total electrons for that. All right, so that's step number 1, add up the valence electrons. Step number 2 then, we're going to get our central atom here. That's going to be the carbon atom. It's the farthest away from fluorine. Again, here's the most electronegative element, fluorine over here. Here's carbon, here's chlorine. So carbon's farther away. It's the first one listed in the formula. That's a good clue that it's the central atom and that it's present in the fewest amount. So we'll make carbon the central atom, and then we'll just attach all 4 chlorines to the carbon atom. So there's our 4 different chlorines. So remember, each line there represents 2 electrons for this. So we got to remember that when we're adding up our electrons. So we've already put 8 electrons into the structure of the 32 for this. All right, so the next thing, so we bonded everything together now. The next thing is add any remaining electrons as electron pairs to complete the octets. We're going to start with the end atoms or terminal atoms here. That's the 4 chlorines. So we do the central atom last. So for example, this chlorine right here already has 2 electrons, and so we need to bring that up to 8. Remember, the octet rule is what we want as the total number of electrons is 8 around each atom. So we've already got 2 there, so it needs 6 more. So there's 1, 2, 3, 4, 5, 6 electrons around that. That completes the octet around that chlorine. The other 3 chlorines work exactly the same way. So we'll just add 6 more electrons to that. That completes the octet there. And 1, 2, 3, 4, 5, 6 more there. And we'll do the same thing on this one. All right, so that completes the octet on each of the 4 chlorines. And kind of when you finish this step, take a look, add up all your electrons and see if you've used them all, or what, kind of what you need to do next for that. And if we look here, there's 2, 4, 6, again, there's 2 electrons there, so that makes 8. There's another 8 there to make it 16. Here's another 8, that brings us to 24, and another 8 electrons brings us up to 32. So I've put all 32 of my electrons into this structure. Again, you have to use all 32, no more and no less for that. And so at this point then, we've completed the octets on the 4 chlorines, and if you look at the carbon atom, when we attach those 4 chlorines to the carbon, that completed the octet for the carbon, 2, 4, 6, 8. All right, so we don't really care how many it started with. All we care about ultimately is how many that carbon atom ends up with. It has to end up with 8. All right, so it only started with 4, but it ends up with a total of 8. All right, so that's all the steps then for that. All right, let's do this one down here. Let's do NF3. And so let's again start off by figuring out how many electrons each of the elements is going to have, or electrons each element's going to have there. Here's nitrogen right here in column 15. It's going to have 5 valence electrons for that. So let's just write it off on the side there. So we're going to have 5 electrons from the nitrogen, and then we have 3 fluorines, 3 F atoms, and each F atom's in the same column as chlorine. It's going to have the same number of valence electrons as chlorine then. 7 for each of those 3. So 3 times 7 for that. And so when we add 3 times 7 is 21 plus 5. That means we have 26 electrons to go into this structure. All right, so same idea here then. We need to figure out what the central atom is. Nitrogen is going to be the central atom. There's only one of those versus 3 fluorines. Of course, fluorine is the most electronegative element. So there's my nitrogen. Let's put a fluorine this way. We'll put a fluorine up here, and we'll put a fluorine over here. It doesn't really matter where we put them around that central atom. I just like this kind of upside down T shape for this. All right, and so again, we've used 2, 4, 6 electrons just attaching those 3 fluorines to the nitrogen. So the next step is to complete the octets on the 3 terminal atoms here. That's the 3 different fluorines, just like we had with the chlorine example. There's already 2 electrons, so we just need to add 6 more to that. So 1, 2, 3, 4, 5, 6 there, and we'll add 6 more in on this one, and 6 more here, and that will complete the octets on all 3 of the fluorines. All right, so now let's just stop for a second and figure out how many electrons we've used. Remember, the line here, the bond, is 2 electrons, and there's 3, 4, 5, 6, 7, 8 electrons then around that. Another 8 here is 16. Another 8 here is 24. So at this point, the structure has 24 of the 26 electrons in there. So we need to add 2 more electrons, and that's where we go to the central atom then. Right now, that nitrogen has 2, 4, 6 electrons around it, so it works out. It needs 2 more electrons then, and that's what we had left to put in. So we put those in as a lone pair on the nitrogen. That's going to be really important when you look at the shape of that molecule. All right, and so that's the Lewis electron dot structure, sometimes called an LEDS, for the molecule NF3, or nitrogen trifluoride. All right, so let's try water. Let's do H2O here as our last system. And so we'll bring back in the periodic table. Again, hydrogen's not going to be the central atom here. Oxygen will be, but the hydrogen was listed first. There's 2 hydrogens. So with 2 hydrogen atoms, it's over here in the first column, only 1 valence electron for that, so it'll be 2 times 1 for that. And then my 1 oxygen, here it is here in column 6A or 16, and it's going to have 6 valence electrons for that. And so 2 plus 6, that's going to give us 8 total electrons then to go into this structure. And so as I said then, oxygen's going to be the central atom, and we'll just have the 2 hydrogens coming off of that. And the nice thing about hydrogen, just remember it's one and done for hydrogen. You only need 1 bond, that's it. You're not going to have any lone pairs or anything else around a hydrogen. Just that single bond here, single bond there, and those 2 hydrogens are all set. It only needs 2 electrons so that it has that filled 1s orbital then, that first energy shell, just like helium has. So that takes care of 2, and 2 is 4 of our 8 electrons. So we need to put 4 more into the structure, and of course they're just going to go in around the oxygen. 1, 2, 3, 4, and that completes the octet around the oxygen. There's 2 here, 2 here, 2 here, 2 here, so 2, 4, 6, 8 electrons around that oxygen, and that's the Lewis electron dot structure for water. All right, so look for the next video. It'll have some examples that are a little bit more complicated.